Today's question is, why does the Earth go around the sun? And I want to warn you right away, whatever you think the answer is, it probably isn't quite right. In fact, I'm even going to say something that sounds outrageous. It's not because of a force. Now, today we're going to talk about something everyone believes they understand. Children learn it in school, grown-ups nod wisely when it's mentioned, and scientists use it every day. But the moment you really stop and ask, what is it exactly? That's when the trouble begins. We're going to talk about gravity. Now, everybody knows about gravity. You drop a plate, it falls, you slip on a banana peel, you hit the ground. It is the most common experience of your life. It is the glue that holds you to your chair right now so you don't float up to the ceiling. But I want you to look at something bigger. I want you to look at the solar system. We have the sun. It is a giant burning ball of gas. And we have the earth, a rock. And the earth goes around the sun, round and round like a clock. Now why? Why does it turn? If I take this piece of chalk and I tie it to a string and I swing it around my head, whoosh, 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 it goes in a circle. Why does it go in a circle? Because I am pulling it. I can feel the tension in the string. My arm is pulling the string is pulling the chalk. The chalk wants to fly away. It wants to go in a straight line. That is the nature of things. Inertia. Things want to keep doing what they are doing. But the string says, no, come back. It pulls it inward. Now, if I take a pair of scissors and cut the string, what happened? Does the chalk keep going in a circle? No. Does it stop dead in the air? No. It flies off. It flies off in a straight line, tangent to the circle. Goodbye. So we look at the earth and the sun. The earth is going in a circle, well, an ellipse, but let's not be pedantic. So something must be pulling it. Something must be keeping it from flying off into the dark. I look at the space between the earth and the sun. I look very closely. Do I see a string? No. Do I see a rope? No. Do I see a chain? No. There is nothing. There is 93 million miles of absolute complete nothing. Vacuum. So how does the earth know the sun is there? How does the sun reach out across that empty darkness and pull on the earth? What is the machinery? Now, for a long time, nobody knew. And then came Isaac Newton. And Newton was a giant. He gave us a law. He gave us the mathematics. He said, I don't know what it is, but I can tell you exactly how strong it is. He gave us the inverse square law. He said, the force gets weaker as you go away, but not just weaker. It follows a precise rule. If you move the earth twice as far away, the pull is 1/4. If you move it 3 times as far away, the pull is 1/9. 4 times away, 1/16. And this was a triumph. It was spectacular. With this one simple rule written on a napkin, you could explain the moon going around the earth. You could explain the tides rising in the ocean. You could explain the motion of Jupiter. You could explain why the apple falls on your head. Everything fit. The whole universe was a clockwork machine. But Newton was not happy. If you read his letters, he was deeply worried because he had a philosophical problem. He had a math that worked, but he had no gears. He had no mechanism. He called it action at a distance, and he hated it. How can a body act where it is not? How can the sun push on the earth when the sun is not at the earth? Let me give you an analogy to show you why this is annoying. Suppose I tell you I don't believe in gravity, I don't believe in forces. I say it is angels. I have a theory. My theory is that there are invisible angels flying behind the earth, and they are beating their wings, pushing the planet toward the sun. And you say, Professor, that is ridiculous. And I say, wait, I have more to my theory. These angels, they get tired. If they fly far away from the sun, the light is dim, they cannot see, they get weak. In fact, if they fly twice as far out, they push exactly 1/4 as hard. Now, if I calculate the orbit of the Earth using my angel theory, and you calculate it using Newton's gravity theory, do you know what happens? We get the exact same answer. The mathematics cannot tell the difference between a force and a tired angel. So if the math is the same, how do we choose? Newton didn't choose, he said. Hypotheses non fingo, I frame no hypotheses. He said, look, the math works. Don't ask me about the angels. Shut up and calculate. And for 200 years, we were happy. But then something terrible happened. We discovered something that broke the machine. We discovered the speed of light. We found out that light is not instantaneous. If I turn on a light bulb, the light does not fill the room instantly. It takes time. Now, it is very fast, 186,000 miles a second, but it is for night. It takes about 8 minutes for light to travel from the sun to the earth. This means when you look at the sunset, you are not seeing the sun where it is now. You are seeing where it was 8 minutes ago. You're looking at a ghost. Now, why does this matter for gravity? Imagine a catastrophe. Imagine a magician comes along and snap. He makes the sun vanish, gone. Poof. Right now. According to Newton, what happens to the Earth? Newton's equation has mass of the sun in it. If the mass becomes zero, the force becomes zero. And the equation has no time in it. It says the force depends on the mass right now. So according to Newton, the instant the sun disappears, the Earth should fly off into space. The Earth should know immediately that the gravity is gone. But wait a minute. We just said nothing can travel faster than light. Light takes 8 minutes to get here. So for 8 minutes, we would still see the sun in the sky. It would still be shining. We would still feel the heat. So are you telling me that the Earth would fly out of orbit while we can still see the sun sitting there? That the gravity information traveled faster than the light information? That is impossible. If we can't send a telegram faster than light, how can the sun send a gravity message faster than light? It violates the laws of cause and effect. If the sun disappears, the Earth cannot know about it for at least 8 minutes. So for 8 minutes, the Earth must continue to orbit around a sun that does not exist. It must orbit around nothing. So Newton was wrong. He was a genius, but he was wrong, because his theory required information to travel instantly. And nature says, no, I have a speed limit. Wait. So this leaves us with a deep mystery. If there are no ropes, and if the information cannot get here instantly, how does the Earth know where to go? What is telling the Earth to turn? We need a new idea. We need an idea that explains how the Earth interacts with the sun without touching it and without action at a distance. We need to change our entire idea of what space actually is. We used to think space was empty, nothing. But Einstein came along and said, no, space is not empty. Space is a thing. And that is where the bugs come in. Let me tell you about the bugs. Now, to understand this, we have to use our imagination. We have to be very careful because our common sense is going to fight us. Our common sense tells us that space is flat, like this floor, like a table. If I draw two parallel lines on this table, they go on forever. They never touch. That is Euclid. That is what we learned in grade school. But we have to ask, what if we are wrong? What if we are like a bug? Imagine a world that is only 2 dimensions. Imagine a giant sheet, but this sheet is not flat. It is wrapped around a ball, a huge sphere. And on this sphere, there live some bugs. But these are not ordinary bugs. They are flatlanders. They are infinitesimally thin. They live in the surface. They can move forward. They can move backward, left, right. But they have no concept of up. They have no concept of down. Yuppie is not a direction for them. It is outside of their universe. If you said to them, look up at the stars, they would say, what is uppie? I do not know this word. You are speaking nonsense. Now, suppose these bugs are very smart, but they are scientists. They are the Isaac Newtons of the bug world, and they want to map their world. They think their world is flat. Why shouldn't they? If you look at a parking lot, it looks flat, even though the earth is round. So two of these bugs decide to do an experiment. They stand on what we would call the equator. They stand a few miles apart, and they act very scientifically. They use protractors. They make sure they are standing exactly parallel to each other, and they agree to walk north. Now, what does north mean to a bug? It means a straight line. It means do not turn the steering wheel. Left foot, right foot, straight ahead. They are obsessive about it. They are not going to cheat. They are going to walk the straightest possible line they can. We have a fancy name for this in physics. We call it a geodesic. A geodesic is simply the straightest line you can draw on a surface. On a flat piece of paper, a geodesic is a straight line. On a sphere, well, we will see. So off they go. Bug A starts walking. Bug B starts walking. They are parallel. And because they believe in Euclid, they believe that parallel lines never meet. They expect to walk forever and stay exactly the same distance apart. They walk and they walk. And slowly, very slowly, something strange begins to happen. Bug A looks to his right. Hey, he says, you are getting closer to me. Move over. And Bug B says, I am not moving over. I am walking straight. You are the one drifting toward me. I am not drifting. My steering wheel is straight. Oh, they get angry. They think the other guy is drunk, but they keep walking. They get closer and closer and closer. And finally, at the North Pole, boom, they crash into each other. Now the bugs are confused. They are rubbing their heads. They are sitting in the snow at the North Pole trying to figure out what happened. They review the data. We started parallel. We walked straight. We did not turn. We crashed. There is only one explanation for the bug. There must be a force. There must be some mysterious attraction between them. Maybe they are magnetic. Maybe there is a bug force that pulls bugs together when they walk long distances. They might even write a law. The force of attraction is proportional to the distance traveled and so on. They invent a force to explain why they came together. But we know better. We are the giants. We are standing outside the ball. We are looking down at them in 3 dimensions. And we are laughing. We say, oh, you silly bugs, there is no force, there is no magnet, there is no attraction. You were just following a straight line, but you were doing it on a curved surface. The collision didn't happen because of a force. It happened because of the geometry. The shape of their universe dictated that they must meet. They couldn't help it. There is no such thing as parallel lines on a sphere. Now, this is the moment where you have to hold on to your seat. Because Einstein, he looked at this and he said, we are the bugs. We are living in a universe that we cannot look at from the outside. We exist in 4 dimensions, 3 dimensions of space plus time. We look at the earth. We see the earth going around the sun. And we say, aha, a force. The sun is pulling. But Einstein says, no, there is no rope. There is no pulling. The sun is a heavy object. It is massive. And because it is massive, it bends the space around it. It curves the geometry of the universe. The earth is just like the bug. The earth is trying to go straight. It is doing its very best to go in a straight line. It has inertia. It doesn't want to turn. But the space itself is curved. The straightest possible path, the geodesic, around the sun happens to be a circle or an ellipse. So the Earth falls around the sun not because the sun is grabbing it, but because that is the only path available in the geometry of the valley that the sun has created. It is falling freely. If you're on the Earth, you don't feel a force pulling you sideways, do you? No, you just feel like you're floating in space if we ignore the ground pushing up on your feet. The Earth is simply following the curvature. So we have replaced the angels and the force with geometry. Matter tells space how to curve. Space tells matter how to move. It is a beautiful picture. It solves the problem of action at a distance. The sun doesn't need to touch the Earth. The sun curves the space right next to it, and that space curves the space next to it, and the ripple goes out until it reaches the Earth. Local action, no magic. But there is a problem. There is always a problem. If I drop a ball plop, it falls to the floor. You say, okay, Professor, space is curved. But wait a minute. The Earth is heavy, but it is not that heavy. The sun is huge. It bends space a lot. But the Earth, it's a pebble. The amount of space curvature caused by the Earth is tiny, microscopic. If space was really curved enough to make a ball turn a sharp corner and hit the floor in 1 second, then when you looked across the room would look like a funhouse mirror. Light travels in straight lines. If space was that bent, the walls would look bent. You would see the back of your own head. But we don't. The room looks flat. Euclid works pretty well in this room. So if the curvature of space is so tiny, why does gravity feel so strong? Why does the ball fall so fast? The answer is that we are forgetting something. We are forgetting the fourth dimension. We are forgetting time. We have to talk about the time part of space-time. And that is where things get really weird. So we have established that the bug on the ball thinks there is a force, but really he is just walking on a curved surface. And we said, maybe we are the bugs. Maybe the Earth goes around the sun because the space is curved. But now you have a right to ask me a very difficult question. You should say, Professor Feynman, the bug is on a ball, and I can see the ball is curved. I can look at it from the outside. But we are inside the universe. How can we tell if space is curved if we can't step outside to look at it? This is a very good question. No? How do you measure the curvature of the room you are standing in if you are trapped in the room? To explain this, I want to use a different analogy. I want you to forget the ball for a minute. I want you to imagine a hot plate, a giant, flat sheet of metal, and right in the middle, we put a fire, a heat source, like the sun. Now we live on this plate. We are two-dimensional bugs again. But this time the plate isn't curved like a ball. It is flat. However, we have a rule of physics. Heat makes things expand. Suppose I give you a ruler, a nice steel ruler, and you want to measure the geometry of this world. You walk close to the fire. What happens to your ruler? It gets hot. It expands. It gets longer. Now you don't know it gets longer because you get larger too. Everything expands. But think about what this means for measurement. If the ruler is longer, it takes fewer ruler lengths to measure a distance. If I put the ruler down 1, 2, 3, because the ruler is stretched, the number I get is smaller than it would be if the ruler was cold. Now let's measure a circle around the fire. We measure the circumference, the distance around. We are far away from the fire where it is cool. The ruler is normal size. We get a big number. Then we measure the radius, the distance from the edge to the center. As we walk toward the center, it gets hotter and hotter. The ruler gets longer and longer. We measure 1, 2, and suddenly the ruler is huge. We cover the distance in very few steps. The radius measures shorter than we expect. So we sit down and we do the math. Euclid told us that the circumference c is equal to 2 times pi times radius, r. c equals 2pr. But on the hot plate, because the radius ruler grew, the radius is short. So we find that c is much bigger than 2pr. The geometry is broken. The math of the flat world doesn't work. And we say, aha, our space is curved. We didn't need to step outside. We just needed to measure the relationships between circles and lines. If the math doesn't fit Euclid, you are in a curved space. Einstein says, this is what mass does. The sun is the fire. It doesn't heat up rulers with temperature. It changes the scale of distance itself. Gravity is a distortion of the metric, be the way we measure distance. Close to the sun, there is more room inside the circle than there should be. Now, this is all very fine. It explains the orbit of Mercury. It explains the bending of starlight. But, and here's the headache, does not explain the falling ball. I hold this piece of chalk. I drop it. It goes from 0 to 10 miles an hour in a split second. That is a huge curve. To make a ball curve that much, the space would have to be twisted into a pretzel. But the Earth is not the sun. It is not that heavy. The hot plate effect of the Earth is tiny. It is 1 part in a billion. It is so small you can barely measure it with our best instruments. So if the space is almost flat, why does the chalk fall? Why does it seem to accelerate? If I put a marble on a table that is almost flat, it just sits there. It doesn't go shooting off the edge. So Einstein was stuck. He had curved space, but it wasn't enough to explain gravity on Earth. He needed something else. He needed to look at the full picture. We are not just moving through space. We are moving through time. We have to add the 4th dimension. And when you add time, suddenly everything snaps into place. Let me draw you a graph. So we are stuck. We have the idea that curved space explains orbits. But we found that the Earth is too weak to curve space enough to make this chalk fall. If space was the only thing curving, this chalk would float. It would drift. It would take 1,000 years to hit the floor. But it doesn't. It goes bang. So what are we missing? We are missing the biggest part of the universe. We are missing the 4th dimension. We are missing time. You see, you and I, we are not just objects sitting in a room. We are travelers. We are all traveling through space-time. Even if you sit perfectly still in your chair, you are moving. You are moving through time. And you are not just wandering through time, you are rushing through it. You are hurtling into the future at a specific speed. Do you know what that speed is? It is the speed of light. See, now you say, yes, Professor, that is crazy. I am sitting still. Yes, your speed in space is 0, but your speed in space-time is fixed. You don't use any speed for space, you use all of it for time. Every time your watch ticks 1 second, you've traveled 186,000 miles in the future direction. That is the scale of the universe. 1 second of time is equivalent to 186,000 miles of distance. Now imagine this chalk. It is sitting in my hand. It is traveling up this graph into the future at 186,000 miles per second. It is a race car. It is going like a bat out of hell. Now Einstein comes along and adds one more detail. He says, gravity doesn't just curve space, it warps time. He says that clocks run differently depending on where they are. Down here near the Earth, time runs slow. Up there near the ceiling, time runs fast. Gravity puts the brakes on time. Now the difference is tiny. It is infinitesimally small. A clock on the floor is slower than a clock on the ceiling by a fraction so small you need an atomic clock to see it. But it is there. So let's go back to our analogy. Imagine you are driving a car. This car represents the chalk, and you are driving this car across a giant field. The field is space-time. You are driving mostly in the time direction. You are flooring the gas pedal. You are going 186,000 miles per second. You cannot stop. You cannot slow down. We are all forced into tomorrow. Now imagine the ground is not even. Imagine the left wheels of your car are on night drive pavement, high up, away from the earth. But the right wheels of your car are in the mud. The mud represents slow time near the earth. What happens if you drive a tank or a car where the right track is going slower than the left track? Does the car go straight up? No. The car turns. It swerves. It swerves towards the mud. This implies something magnificent. The falling of the chalk is just the swerving of the car. The chalk wants to go straight into the future, but its feet are in slow time and its head is in fast time. So its path through the universe bends, it curves toward the earth. And here's the punchline. Here is why it falls so fast. You might ask, Professor, the time difference is tiny. The mud is only a little bit sticky. Why does it turn so sharp? It turns sharp because the car is moving so fast. If you're driving 1 mile an hour and you hit a patch of mud, you barely turn. But if you're driving a rocket car at 186,000 miles per second and you hit even a microscopic patch of mud, whoosh, you veer off the road instantly. The turn is violent. That is why gravity feels strong. It is not because the earth is powerful. It is because you are powerful. You are racing through time with such tremendous momentum so that even the slightest warp in time caused by the earth sends you crashing into the floor. So we have solved the mystery. The curvature of space keeps the planets in orbit because they are moving fast in space.